it. Okay, hi everyone. I hope you can hear me or see
Okay,
me.
great.
Awesome. And I'll just start sharing. So you all can see the presentation. That's good. Okay, and you can see it in the presentation mode as well. Perfect. Okay, so in order to make this presentation as interactive as possible, I'm hoping you can type in all the questions, and I'm going to keep the chat window open on the very side of my screen, and I'll take a look at it every now and then to make sure that I'm able to answer all the questions and keep the session as interactive as possible. And of course, thank you everyone for joining in, and hope everyone is staying safe. Today, we're going to be talking about deep learning on mobile. Now, I know that this is a very up and coming topic, but apart from that, what is really the motivation that all of us have joined in this video call? And I know most of us are in very different time zones, so it may be morning, evening, night for some of us. So let's see what the motivation is to know a little bit more about deep learning on mobile. And I hope that we don't experience bandwidth issues throughout the presentation, but the presentation will be available at the end for download. Oh, I see. I'm sorry about that. I see people can't hear the audio from the video. I'm really sorry about that. I can try increasing the volume. I'm not sure if that's actually going to help though.
No, we still cannot hear the audio.
Oh, okay.
Okay, actually now it's better.
Okay, I don't know how I can share audio in Zoom. If you can tell me, because I have a couple more videos coming up towards the end of the presentation, I think that'll be very helpful.
I'm not sure. I mean, if you that one is on the YouTube, you can post the link on the YouTube, but
Okay.
otherwise,
Okay, sure.
not sure how.
I'll probably do that towards the end of the presentation then.
Okay.
The entire videos, yeah. Okay, so a little bit of introduction. I, along with my two co-authors, Meher and Anirudh, collectively have about 20 years of experience in the industry working on AI and mobile devices. And together we've really pooled our knowledge in writing a book that was published recently that talks about practical end-to-end experiments that are possible without a lot of knowledge about deep learning and how you really get started and how you scale up for all these experiments. And this presentation is a short snippet of all the information that is available in the book. So let's talk about why deep learning is important on mobile. First of all, we have privacy. Privacy is really important because people are not interested or not willing to share their data all the time. And apart from that, we also have newer regulations coming in like GDPR, CCPA. Canada has its own regulations coming in, and a lot of countries are looking into how to make sure that the citizens' privacy and their data options are regulated. Then we have reliability. Then we have reliability. And with respect to reliability, people want to depend on their application irrespective of network connectivity or not. So you really want to have the computations happening on the device so that the user does not really have to depend on any network connectivity and so on. And finally, cost. Running a server, running a system 24/7 isn't really cheap, and this seems very obvious with respect to how you want to scale up and scale down depending on your user base and so on. And finally, latency. Why is latency so important? We look at a study published by Amazon, which is the results of an A/B test. Now, this came out back in 2008, but as we will see later on, the results from this A/B test are true even today. Amazon published that with every 100 millisecond increase in latency, they had a 1% loss in revenue. Now, imagine what a couple of seconds can do, really. And we don't even need to imagine that, because 10 years later, about a decade later, Google published a study on mobile site visits where they noticed that with a load time of more than 3 seconds, so if a mobile website took more than 3 seconds to load, more than half the users left the website. Now, if more than half the users are leaving the website, it also means that more than half the users or more than half the revenue is lost. And apart from that, another thing to consider is in the 21st century, let's just say that being attentive is really a skill rather than the default norm. If you were ever to talk about the latency or attentiveness or the equivalent Moore's law of it, you could refer them to these numbers. And these numbers have been there since 1968, and more recently they have also been proven true in 1993. But of course, there may have been some changes with the advent of push notifications, but I think more or less they are almost still the same. So the very first number we have is 0.1 second, which is the amount of delay within which a user still considers the communication and the ongoing interaction to be seamless. For example, typing a character on the screen and having it appear almost instantaneously on your screen or your window. The next one is 1 second, which offers an uninterrupted flow of thought. So the user is still able to see that some processing is happening, but the user is still concentrated on the application or whatever interface the user is using. And finally, we have 10 seconds, which is the limit of attention. So usually if your application takes more than 10 seconds or 10 seconds to do some amount of processing, appropriate input or appropriate communication to the user is really essential to let them know that the computer is taking some more time to process. And usually in these 10-second areas, we have certain animation that informs the user or a certain progress bar that appears. And unfortunately, 10 seconds is also the time I take to think before buying the newest Apple product. So when we talk about the perfect deep learning recipe, we look at 4 main constituents. And these are having a high quality data set. So what data set do we want to start from? Some hardware on which we do the training, large scale training. An efficient mobile inference engine, which we use to convert the trained model onto its mobile equivalent engine. And finally, an efficient model from which to pre-train or fine-tune from. And this sort of develops the entire end-to-end deep learning application. This really describes the recipe for a good deep learning application that can be easily and readily deployed on mobile phones. Which brings us to our next question. How do we actually train our models? Now, let's say you want to learn how to play the musical instrument called the melodica. Now, there are several constituents to this. You would learn how to breathe through the pipe. You would need to learn the placement of the keys, which key to strike when. You would also have to control and regulate your breath a little bit. And you would also need to know a little bit of music, so understand what notes mean and which notes to play when. So I would say maybe give or take 3 months you would take to learn the melodica. But let's say that you already know how to play the piano. So at this point, you know the keys, you know the music theory, and you probably just need to learn a little bit about the regulation of breathing. So this would really bring down the time to train or fine tune your skills from 3 months to about a single week. So as a result, fine tuning is really 4 main steps. First of all, assemble a data set, find a pre-trained model on that data set, and then you fine tune your pre-trained model on the data sets that you found. And then you run using existing frameworks, both which exist for training as well as for mobile inference. So don't be a hero, as one of the deep learning, one of the major personalities in deep learning says, don't be a hero. Is there a question from anyone? Okay, I don't see anything in the chat window, so I'm going to go ahead. Yes, I'll have to search for the YouTube URL, so I'll give them shortly. So let's talk about a very simple training methodology, which is using customvision.ai. And this is simple because you really have to upload images to a web browser, allow the web browser to train, and you don't need an external GPU or compute to really do the training. And finally, the evaluate methodology, in which you can define what metrics to use and so on. And one pro tip is to use the Fatkin browser extension to automatically download images. And using this extension, you can also define what kind of images you want, some specific objects in the image, the size of the image, the open source license for these images if they exist. And apart from the Fatkin browser extension, you can also use the Bing image search API to programmatically download all these images with proper rights. I see someone has posted the YouTube link. I hope that's the correct one, but if it is, please feel free to open it maybe after the session. So now that we've uploaded the images to the Custom Vision website, all you need to do is define what kind of task it is. So what are the different labels? Is it a recognition task, detection task, segmentation task? And also upload the ground truth labels with it as well. And finally, the testing is as easy as clicking a single button, which is the quick test button, and you get the precision and recall values for all the different classes that you had trained on originally. Now, coming on to how do we run these models? So depending on what hardware you want to ultimately train on, there is a variety of options to choose from. Let's say if you're developing solely for the Apple ecosystem, you would want to go with 4ML. But if you have a choice of both Apple and Android development, you can go with TensorFlow Lite. And more recently, we also have MLKit, which is an abstraction over TensorFlow Lite. And of course, it supports both the Apple and the Android ecosystem. Talking in detail a little about the improvement in the deep learning deployment, especially in the Apple ecosystem, we see that Apple started focusing on deep learning or AI deployment as early as 2014, when they released a very low-level library called Metal. And Metal was a little bit difficult to program in because you had to combine all these low ops, for example, like addition or a multiplication op, and combine them into the entire ImageNet or ImageNet trained inception model. Now, as an example, I believe the Inception v3 model, which was released as one of the example codes by Apple, had around 2,000 lines of code, which was just the model definition, excluding all the data processing, all the data flow and everything. So that was pretty bulky. Now, slowly, Apple was able to improve all the deployment software as well as the hardware. And now Apple has the A11 Bionic chip, which really helps faster processing, especially for deep learning networks. So concentrating a little bit on the, so we have a question, how do you choose between TensorFlow Lite and MLKit? We will come to that when we start talking about the Android ecosystem in just the next couple of slides. So talking about CoreML2, which came about in 2018, CoreML2 was the second iteration of CoreML, which was a focused software that really focused on the Apple deployment of deep learning networks. CoreML2 allowed the ability to ship really tiny models, often around 1 kilobyte, which really helped in deployment on resource-constrained devices. Also, you could save a lot on the battery power, which was a big concern for developers. Apple originally started providing quantization back in 2017 with the first CoreML release. They had quantization support of 32-bit and 16-bit, but in 2018, they released quantization all the way to a single bit. So you could really reduce the precision value in these models, and you could really make them much smaller than before. Another improvement that Apple introduced was to allow batch support. So you could do computation on multiple inputs at the same time, which was much more quicker and efficient. It had conversion support from MXNet and Onyx, so you could open up the ecosystem to all possible training frameworks. And it also introduced TF CoreML, which allowed direct conversion from TensorFlow to CoreML. So I have a question, would it work on other devices like Surface Pro? So Surface Pro, I would say look up Custom Vision, which was the API that we discussed previously. And from Custom Vision, you can train a model, export it, and put it on Surface Pro all in one go. So you wouldn't really have to look at CoreML, because again, CoreML is focused on only the Apple ecosystem. So Surface Pro is a Microsoft product. So you would look at some of the software like the Custom Vision AI that comes from Microsoft itself. Now in 2019, which was during last year's WWDC, Apple released on-device training, which sort of really changed the game because you could have personalization for each model depending on how the user has been using their app. And this was also very sort of a very secure way to do the training because the data never left the user's device. And they also employed different training strategies depending on which they were able to solve the cold start problem. And we'll see later on that federated learning was also important to consider for on-device training. Now, as a result of on-device training, personalization came about because every person's model was tuned to just their data. They also released a very easy to use user interface that you could just drag and drop to do the training and inference without writing a single line of code. And in the end, you would have an app to deploy on your mobile devices. Does the on-device training use the GPU for backpropagation? Yes. So Apple devices have this A11 Bionic chip that when you choose to do on-device training, that will be used both for the training as well as the inference. So yes, in short. So looking at the benchmarks, which is really how software and hardware both changed in the previous 5 years. So we see in the previous years, when we look at software improvement, CoreML runtime has improved by about 38% across iOS 11 and iOS 12, which is the more recent, at least as of last year. And when we look at the hardware side, we see that something similar really happened in hardware. Execution times of a lot of the models has reduced by even more than half when compared to the software side. And when we look in detail, what really brought about this revolution, it's the fact that GPUs became a thing. And as the rise of GPUs on mobile phones became more and more available on more and more Apple devices, the execution times of various networks on various hardwares really reduced by a lot. So now on to the TensorFlow ecosystem. Now, by and large, when we look at the TensorFlow ecosystem, they didn't really have a very mobile-friendly strategy. Initially, the idea was to convert TensorFlow from the bulky software as we know it to mobile, but it was still a very bulky software to run even on mobile. Then TensorFlow Mobile came out in 2016, which really tried to strip away all the unnecessary lines of code and unnecessary libraries in TensorFlow and keep only the essential for TensorFlow Mobile. But this was still a little bulky. And finally, in 2018, they released TensorFlow Lite, which was extremely small. It was much more faster than any other iterations of TensorFlow on mobile. And it had minimal dependencies. And it was really developer friendly because it allowed running custom operators. I see there are a couple of questions here. What is your view experience regarding using training on cloud and then maybe deploying the model on the phone? Yeah, that's a very doable option. I mean, I've trained many times on cloud and deployed on phone, just for an example. You can use customvision.ai. You can train on a data center worth of cloud. You can train online on AWS or Colab or anything, and then deploy it on mobile phone as well. I think that's a very doable thing, and it's very possible. The next question is it possible to configure a GPU limit in TensorFlow? Yes, there is. When you're training with TensorFlow, you can define how many GPUs you want to use, which particular GPU you want to use by giving the GPU ID. So it's very possible. So moving on, TensorFlow Lite is extremely small when compared to TensorFlow Mobile, which is at 1.5 megabytes. Whereas TensorFlow Lite is extremely small, and in fact, coupled its core interpreter and all supported operations together, the maximum size that TensorFlow Lite will reach is around 300 kilobytes, which is the best for mobile devices. I believe, so another question is, I believe training on phone can't be better than training on cloud. So one thing to consider here is you would train on phone for personalization on a limited amount of data, right? Whereas when you're training on cloud, it is more likely that you will have a much more broader array of data available to train on the cloud. And of course, training on cloud has relatively more resources and more time, more compute available, so you can train on a more stable fashion than on mobile, which is usually oriented towards a limited amount of data for a limited user and mostly for personalization criterias. Then we have Okay, another question is, do I need to do the quantization to use TensorFlow Lite versus TensorFlow Mobile? No, you don't need to specifically use quantization. You can deploy it without using quantization. And again, TensorFlow Mobile is the previous version of the library. TensorFlow Lite is the more latest version, which is used predominantly nowadays. So it's not always a question of quantization or not, but it's also about which is the most latest library that allows you to deploy much more quicker and easier. Okay, so back to the presentation. TensorFlow Lite is fast predominantly because it takes advantage of on-device hardware acceleration, which means the GPUs that are embedded in the Android phones. As an example, these can be different Snapdragon chips or Qualcomm chips or what have you in your Android phones. There is usually a specific GPU with its own specific library that TensorFlow is able to tap into and accelerate the processing. It also takes advantage of flat buffers as opposed to proto buffers, which is what TensorFlow usually uses. Now, flat buffers really came into light when for video and graphics, because they really reduced the code footprint and memory usage, especially in video and graphics scenarios. Now, using flat buffers in TensorFlow Lite really reduced the CPU cycles with which the compute happened, and as a result, made it more friendly for mobile devices. Another thing that flat buffers really shown in is it improved the startup time. So when you open an application, you don't really have to wait for a really long time for the application or the model to really warm up and come into action. Another question is TensorFlow Lite appropriate for all kinds of models, regression, classification, or clustering, or is one more appropriate? So I'm glad you really asked that. And when we look at MLKit, which is an abstraction over TensorFlow Lite, we see that they have released examples of most of these different kind of tasks, like regression tasks, classification, clustering, and so on. So they've really provided easy to use hands-on example, which makes it seem that TensorFlow Lite can be used for all kinds of examples and not just one. Another question is, what do you mean by personalization when it comes to training a model? I'm just going to scroll up because I seem to have lost the question. Okay. So personalization when it comes to training a model. Okay. So the idea of personalization is to make a model more oriented towards each specific person that is using your AI application. Now, in order to do that, you want to do a certain round of training or fine-tuning specifically for that user, depending on the data that has been collected by the user on the user's device itself, right? So that's where the personalization comes in, because you're tuning a model specifically to each user that is using the model. And that model will be very different to the other people who are using your AI application or the model that comes in default with the AI application. I hope that helps. Another question is there an intersection commonalities between training on phone and training on edge? Of course there are. The training procedure is more or less the same, because you're still going to be fine tuning, you're still going to be having a forward pass, a backward pass, back propagation, and so on. So there are a lot of commonalities. It's only the scale is very different. Now, scale of both the data and the resources that are available to do the training. But in a sense, it's really the same thing happening on different devices. So phone, edge, data center, and so on. Have you tried TensorFlow JS on mobile devices? For example, in the progressive web apps, Cordova, React native applications. If yes, what do you think about the performances compared to TensorFlow Lite? That's a good question. I do have experimented with TensorFlow JS on mobile devices. I don't have the exact numbers on top of my head right now, but I will say that I have, for example, there are published numbers in the book that I referred to earlier, as well as I can point them out later on. Like we have a specific table that really compares different mobile web browser-based mobile frameworks like TensorFlow JS. And there are so many others that are available out there. And we've done a really end-to-end comparison of the startup time, CPU cycles, memory cycles, how much is taken for each.
Hey, sorry, interrupt. I'm not sure how long your presentation is going to be. We seems I have a lot of questions, discussions, which is good. But we only have like less than 20 minutes. So maybe you want to, finish your presentation and leave the Q&A at the very end.
Of course, yes. Let's do that. Thank you for keeping me good on time, Bill.
Sure.
So I'll concentrate a little bit more on the presentation right now. Then we have prefused activations in TensorFlow Lite, which really means that it's combining some of the batch normalization layers with the previous convolution layers, combining the computations and making it into one single compute or layer. And finally, we have the static memory and static execution plan, which in TensorFlow Lite really decreases the load time for the startup of various applications. So as we talked about, TensorFlow Lite is much smaller, it's much faster, it has minimal dependencies, and it allows running custom operators, which was an improvement over TensorFlow Mobile. Now, let's say if you wanted to convert to TensorFlow Lite from a framework like Keras, there is one single line command that you can run. And one of the big advantages in TensorFlow Lite is that they released a conversion command line toolkit called tf-lite convert, which makes the conversion really much more easier than what was seen in Onyx or through MXNet. So by far and large, the usual mode of training or the deployment pipeline looks something like this. You have the trained model, you use the TF-Lite converter, you get the TensorFlow Lite model, and you can deploy it both on the Android app and the iOS app. And of course, for the iOS app, you will use the CoreML tools container converter to really convert it to the CoreML model. Now, MLKit, it's a much more easier to use abstraction over TensorFlow Lite. It has built-in APIs as well as lots of examples that are available, and you can really start looking at them. And these examples range all the way from vision tasks like labeling, detection, all the way to NLP tasks like having a smart reply or even face detection like landmark detection and so on. Then it also integrates really easily with Google Firebase. And because of that, it really opens up a slew of some production ready options like the ability to do A/B testing or model management or providing secure infrastructure. By secure infrastructure, I mean keeping the model secure and not letting the users see the model weights or the model network or the architecture, I mean. And it's really simple to use. You can have a face detector model in just about 4 lines of code. And of course, there are a lot of examples that have been released that show how quick and easy it is to use MLKit. Now, talking about how do you keep your IP safe, because not everybody who is using our application may have the good interest in mind. So how do you make sure that your model architecture and model weights are kept safe? Well, one very simple example comes through Fritz, which is a young Boston startup. Similar to MLKit, they have full-fledged mobile lifecycle support. They have really complete documentation about deployment, instrumentation. They have complete Python command line examples, as well as full-fledged end-to-end examples that really talk about how to use various examples that they put out there. And one of the most important things that Fritz has brought about is the ability to do automated model management and model protection. So it really obfuscates the weights and the architecture of the model when you release it. So a person, if he's trying to tamper with your model, that would be disallowed. Now, another thing to consider is how do you make your model really small? How do you reduce its model weights and make sure that this is the absolute best you can do when shipping it off to a resource-constrained device? A few things to consider in this is that Apple doesn't allow an app size over 200 megabytes to be downloaded over cellular network. So one option to look into is to download on demand and interpret on device as needed. Now, what this really means is that you can download the basic model or this basic framework of the network. And when the model is run, you really download the necessary weights and if necessary, additional layers that allow you to interpret on the device. Now, recall that Core ML allows you to ship a kilobyte worth of model. And this is really where it shines to have the interpretation on device really helps the model size to be really small when you initially ship it. Now, we will be looking at comparing the hardware performance on the performance of AI application. Now, we know that over the years, the hardware specifications have really improved. But if we look at some of the latest, as an example, the iPhone Pro, we see that it's actually much more faster than a laptop like the MacBook Air. And this is a video. I hope there is no lag in it. There's no audio in this video. So I think we're okay on that end. But we see the lag come into picture here, which is comparing various generations of iPhone over the years. So on the very left side, we have the iPhone XS, which is the more latest iPhone that is available. And we see that a real-time segmentation network running on it is more or less, sort of real-time, and it seems seamless. Whereas for the other two devices, the segmentation isn't as real-time, and we can see some patches come into the screen when the network is doing the segmentation on the video. There are two really good sources to consider when looking at hardware specifications. One of them is TensorFlow Lite benchmark, and the other one is specifically for open source devices, both software and hardware, and we'll be looking into that shortly. So this website called the AI Benchmark is really an application that you can download on your phones. It'll run a slew of hardware test benches ranging from face detection, some NLP oriented networks, and it'll really benchmark and upload the results on all these 9 test benches for each hardware. So if you're developing for a specific hardware platform, you can see what are the timing constraints that you have to be under to make sure that the mobile is able to process your networks correctly and is able to provide the output to the user in a specific amount of time. Another library to analyze and estimate mobile performance is Alchemy, again by Fritz. And this is really good because you don't even need to deploy on a mobile phone to test this out. all you need to do is to run it on a command line on your laptop as an example, and it'll show you the ops that are used in each layer of the network. And you can use this for really focused understanding of which layer to reduce further or which compute to further reduce. And it really improves your overall the compute that is necessary for a resource constrained device. Now, let's say you are developing for the previous 4 years of all the hardware that has been released in the previous 4 years. Now, this really puts you in a good vantage point because you are able to get at least 95% of the devices that the global population will be using. And when there are cases of unsupported devices, you can always offer graceful degradation, for example, running the network at a lower frame rate or having the inference done on cloud and pulling the output on the device to show the user. Now, energy or battery usage is a very big consideration, and users are pretty vocal when it comes to their battery being utilized or being overutilized by a specific application. And of course, this is something that no mobile developer really wants to have. So here are some energy considerations to keep in mind. First of all, you do not have to run your AI model constantly. You can run it for a few seconds and provide the results based on that. And within a flagship phone, if you were to run, let's say, MobileNet at 30 FPS, you should burn the entire battery in about 2 to 3 hours worth of time. But the important question to consider is that even necessary? Do you even need to run it at 30 FPS? And in fact, we ran some benchmarks and we saw that there is a huge amount of energy reduced when you run from 30 FPS to 1 FPS without much change in the results. Because the results on a per frame basis, so you're not really changing much of the results. So this is really important to consider, that you don't necessarily need to run all the networks on a 30 FPS on a more real-time basis. You can reduce the frame rate and have the results appear almost seamless to the user at the same time as the user would like to see them. Now I have some exciting applications that users have built all around, and this is going to be a bunch of videos.
Oh, by the way, is this video have a audio, have a voice?
Yes.
I think there is an option in the shared screen button. Say, you can share the audio through the computer audio. Can you quickly check if that one available to you?
Okay, share computer sound. Okay, I see it.
Yeah.
Sorry about that. I'm playing it again.
Processing.
Good.
Expo low odor dry erase markers with chisel tip 4%. Assorted.
All right. So the context of this is really that the blind community, when they go into shopping malls, originally, they were provided with these really heavy and bulky barcode readers. And these barcode readers are traditionally very expensive. And in fact, charities would raise millions and millions of dollars to provide a community with these barcode readers. So Microsoft came up with this application known as Seeing AI, which really helped recognize the barcode and use appropriate audio cues in it. And of course, this application has a whole slew of other relevant applications like reading a document, describing an image or image captioning and so on, apart from the barcode reader that we just saw. Here is another example of the AR hand puppets. This is by 2020 Computer Vision or 2020 CV. this example uses hand detection for object detection for the hand and key point estimation to place the rabbit puppet on the hand itself. This is a company called Home Court AI, and this is actually being used by the NBA for training their players. And a couple of things that are really important in this is that this this company is able to generate a view of the court that really shows the player where they were able to have the maximum baskets from and what are the places that they can improve. And if you look at the scoring, it also really focuses on the player rather than the other people like the coaches or if anyone else is on the court. It really focuses on a single player and is counting the baskets only for that player. Now, how many of us like Sudoku? I personally love Sudoku, but it's a little too much to solve it all the time. That's why we have an application that can do it. So this will be a little loud, so I'm going to reduce my laptop volume a little. I was just as confused as you guys when I first saw this. So now how do we make our models more efficient? A question to Bill, how much time do we have?
About 5 minutes.
Okay. 5 minutes for the presentation or 5 minutes and then we have the QA?
5 minutes. 5 minutes we have to end the
Okay.
meetings.
So
But we can extend a few more minutes. But yeah, probably 5 minutes to finish the presentation and a few minutes for the Q&A.
Okay, so post this, I was really going to talk about some quantization techniques, pruning. How do we do pruning, and how do we look at pruning in Keras as an example? It's really just a one-line command that allows you to prune, especially in the latest version of Keras, which really makes it much more easier to do. And I think it's good to break for questions. So I'm just gonna see if I can bring up the chat window somehow. Okay.
Yeah, I mean, if you have still too many slides or content left, maybe we can just kind of like stop here for some Q&A and maybe schedule another sessions later on.
Yeah, so there are really 2-3 things that are left. A little bit of quantization, neural architecture search, and federated learning, which was in relation to the on-device training in CoreML. And all of these require a sizable bit of discussion. So I don't want to, leave people hanging in. Oh, really, I don't want to do that. So I can, obviously, I'll be sending over the presentations. So I'll probably just open the slide. You can access the slides from this URL. And please feel free to look at the slides and other information. And while we're doing this, I can look at some of the questions. Slide 42, someone wants to look at slide 42. I'll be sending over the presentation, so you can probably see that. What is your opinion in training on the personal PC with maybe several GPUs? Yeah, that's definitely doable. You can, whatever framework you choose, you can specify the number of GPUs you want to train on. You can specify what particular cycles should occur on GPUs. You can put in more prefetching, queuing, for improving your data processing cycles. So all of that is possible. I see some questions on the format of images as an example of frames. Do you train models on YUV420 for mobile? I don't think training is really format dependent, format of the image dependent. You can always have some data formatting and converting from one format to another. That's definitely possible. On iOS, is MLKit as performant as CoreML? Yes, but always remember that CoreML is really simplistic when it comes to deploying on iOS devices. So it's usually preferred to convert to CoreML ultimately. Any hope for PyTorch people for mobile? That's a good question. And although PyTorch is really, it's really good at training, I haven't seen much in mobile. But of course, you can always convert PyTorch to Onyx, Onyx to TensorFlow or Keras, and then eventually to MLKit. That is definitely a path that goes from PyTorch to mobile devices. So I see a couple of questions about the slides. Yes, the slides are available if you go on the website link. So this one, practicaldeeplearning.ai. You will be able to see the presentation uploaded over there. So the don't be a hero slide really means that don't start training from scratch, do fine tuning or do transfer learning from a pre-trained model. Are there any optimizations in training on device to make it faster, mainly other than fine tuning only a few layers? Yes, you can always add additional optimizations while training on device. But I'm not sure the context of this question a little bit, like why would you want to do optimizations on device? You know, because the network optimization is already there when you're sending the model to the device. So are you talking about having additional optimizations done at runtime on the device? I'm not sure if that's the question or not. I'm gonna copy paste this URL as well, but I see someone posted the SlideShare link and that is correct as well. Have you used model asset exchange? I have used, for example, Model Depot that has come out in TensorFlow, but I haven't used model asset exchange. I'm not sure what exactly is it, but by the name, it sounds like it's more or less similar to like a Model Zoo or Model Depot that exists in various frameworks where you can pull different models and really start fine tuning or transfer learning from them.